Good morning. I'm Dr. R. Parameswari, Assistant Professor, Department of Mathematics, Satyabama Institute of Science and Technology. Today we are going to see change of order of integration as part 2. In the previous part, we have seen the problem based on the straight line. In this part, we are going to see the problem based on the intersection of two parabolas. Here also we are going to change the order of integration and evaluate. But here the limits are different. Okay. And we are having the limit as integral 0 to 4a and integral x squared by 4a to 2 root ax, xy dy dx. So what is the first step? We have to check the order, given order is correct based on the given limits. We can't change the limit. We can't change the limit depending on the order. We have to check the order. If the order is not correct, then we have to change the order. Rewrite the question in the correct order and then only we can proceed for the evaluation. Okay. So now the inner integral limits are function of x. Function of x means it should be with respect to y. The inner integration must be with respect to y. So we are having the given order as the correct order. No need to rewrite the question. So once the order is correct, what we have to do? We have to write the limits. Y varies from x squared by 4a to 2 root ax. And you know, if you are seeing the curve itself, you can identify that both are the parabola. Okay, it is x squared is equal to 4ay and y squared is equal to 4ax. So the parabola symmetrical about x-axis, symmetrical about y-axis we are having. Okay, and the limits for x varies from 0 to 4a. So 0 to 4a, x is equal to 0 is a limit, that is nothing but the y-axis, and x is equal to 4a, that is a constant limit. So that constant is parallel to y-axis. We are going to draw the line, that's all. Okay, and the region of integration is enclosed between the curves x squared is equal to 4a and y squared is equal to 4ax and the lines. So the two parabolas will intersect at the point 0, 0 and 4a, 4a. Okay, so that is what it is mentioned in this diagram. We are having x squared is equal to 4ay, y squared is equal to 4ax. And those parabolas are intersecting at the origin and intersecting at the point 4a, 4a. Okay. Now, what we have to do? We have to change the order of integration. So, once if we are changing the order of integration, the given order is dy dx. Now, we have to change the order as dx dy, dx dy, okay. And if we are changing the order, which strip we have to draw? With respect to x, we are going to integrate first. So, it must be the parallel strip. So, that is what mentioned here. It is a parallel strip drawn in this region. This is a region bounded by all the boundaries. 0, 0 intersecting point, 4a, 4a intersecting point, and the parabola y squared is equal to 4ax, parabola x squared is equal to 4ay. So, this region is bounded by all the boundaries. So, in that region, we are drawing the strip. The strip horizontal, parallel to x-axis, because we are going to integrate with respect to x first. So, we are going to find the limit for x. We are going to find the limit for x. And what about the left end of the strip? It is touching the parabola y squared is equal to 4ax. It is touching the parabola y squared is equal to 4ax. We need the limit for x. So, what is x is equal to? Y squared by 4a. Okay, x is equal to y squared by 4a. And the right end of the strip is touching the parabola x squared is equal to 4ay. And it is in the first quadrant. In the first quadrant, both x and y are positive. Even we are having x squared is equal to 4ay means we used to write x is equal to plus or minus 2 root ay. But we are going to take only the positive value because the region is in the first quadrant. The region is in the first quadrant. Okay. So, we are having the upper limit of x as x is equal to 2 root ay. So, the inner integral limits are over. Now, we have to find the outer integral limit. How we can find? By moving the strip towards downward direction and towards upward direction. So, moving the strip towards downward direction, where it will meet? The intersecting point 0, origin 0, 0. So, y is equal to 0 at that intersecting point. and moving towards upper direction, it will meet the point 4a comma 4a. So, at that point, y value is 4a. Okay, y value is 4a. So, y varies from 0 to 4a. Now, we can change the order and then integrate. Now, we are having the function, given function is xy, dx, dy. Written the limit of x and limit of y. Once if we are integrating with respect to x, we have to treat y as a constant. So, the integral value is x squared by 2 into y, x squared by 2 into y, and the limits are lower limit is y squared by 4a, upper limit is 2 root ay. Now, substituting the limit, this function becomes function of y alone. Function of two variable is reduced to function of single variable after integrating with respect to x. Function of y we got. Okay. Now, this is function of y we are having. Okay. After finding the function of y, we are going to integrate with respect to y. So, what we are having 2a y squared minus y power 5 by 32a squared. Integrating that, 2a is constant, integral of y squared is y cube by 3, and 1 by 32 a squared is constant, y power 5 we are having, so integrating y power 6 by 6, and that is between the limit 0 to 4a. Now, substituting the limit. Substituting the upper limit, if we are substituting the lower limit, we are going to get it as 0. Only for the upper limit we will get the value. Okay. So, 2a into 64a cube by 3 y cube, 4a the whole cube. So, it is 64a cube and y power 6. So, 4a the whole power 6. So, simplifying, we are getting the answer as 64a power 4 by 3. So, the given integral, we have changed the order and evaluate that integral value as 64a power 4 by 3. Thank you. We will meet in part 3. In part 3, what we are going to see is how the region is going to divide into two sub-regions and then how we can evaluate it. Thank you.